Hi, this is Mr. Bo, and today we're going to talk about subsets and power sets. This is part one about subsets. What is a subset? A subset uses this symbol here, which looks a little bit like less than or equal to, and it looks a little bit like less than or equal to because that's kind of what it means. So if we have two sets, A and B, then A is less than, A is contained by B. And we say all elements of A are also elements of B. And you'll hear me say that like 20 times today. So all elements of A are also elements of B. What that means is if A is equal to B, that's also true. All elements of A will be B if they're equal, which is why we have this little kind of like less than or equal looking sign down here. Here's an example. Here are some regular polygons, and they are a set inside polygons here, and we can see that all the regular polygons are also polygons. So the set of all regular polygons, all the elements, are also elements of polygons. So regular polygons is a subset of polygons. And down here we can see that this transfers as a transitive. So if A is a subset of B and B is a subset of C, then we know that A is a subset of C. Just like if we know that 3 is less than 4 and 4 is less than 5, then 3 is less than 5. So we're going to start with one problem. First problem, set A that has elements B, J, I, H, G, F, A, and set B has one element, which is G. So I'm going to go ahead and write these down over here. A is equal to B. Well, that was not good. There we go. A is equal to B, J, I, H, G, F, and A, and our set B is equal to, has one element, which is G. So we want to know, is A a is B a subset of A? A is definitely not a subset of B. Is B a subset of A? Alright, so we're going to check to see if all of our elements of B are also in A. And we have one element, it's G, and that's also in A. So if I draw a Venn diagram, I have A, and then over here I have set B, and in set B there's G, and then everything else is outside. So our Venn diagram looks like that. And what we can do to check is that we can take the difference. So the difference of A and B, so if we take I'm going the wrong direction, sorry. So if we take the difference of B and A, so we take all of A out of B, then we're going to be left with the empty set. There's nothing there. Okay? So that's our first one. That's our first problem. Our second problem is set A is HAFIEGLMB, and set B is CIKLJA. So this is a little bit more complicated. So set A is equal to HAF. Oh, what happened there? There we go. Set A is equal to HAFIEGLM and B, and set B is equal to C, I, K, L, J, and A. So what we want to know is B a subset of A? Okay. Is B a subset of A, or are all the elements of B in A? So I'm going to look for C and try to find C up in here, and I can't find C. I can find I, and I can't find K, and I can find L, but I can't find J, and I can find A. So the answer is no, and we know that because if we take the difference here, we're gonna get some elements left over, and if we draw the Venn diagram, we're going to have these C, J, and K out over here, and I, L, and A up over here, and then we're going to have H and F and E and G and M and B. So it's going to look like that if we do our Venn diagram. So let's get ready for number 3, make sure that's going to work. Okay. So we can see that our answer, whether B is a subset of A, is false, and that our difference, there's something left. So we have 2 more problems really fast. Problem number 3, our set A is AG, J, I, M, D, B, K, and our set B is AG, J, M, D, B, K. All right, so we want to know is B a subset of A? So let's look at it. The set A is equal to A, G, J, I, M, D, B, and K, and set B is equal to A, G, J, M, D, B, and K. So what do we want to do? If we want to know if B is a subset of A, we want to know is every element of B also in A. Well, let's see it. I see those. A is G is in B, it's also in A. J is in B, it's also in A. M is in B, it's also in A. D is in B, it's also in A. B is in B, it's also in A. And K is in B, it's also in A. So we can say that that is a true statement. And if we draw a Venn diagram here, we're going to have A, G, J, M, D, B, and K down here, and we'll have basically just I sitting out there in set A. And so we can see that if we take the difference, we're going to end up with the empty set. All right, we have one more to do quickly. Problem 4. So I'm going to go ahead and skip over here. Kind of running out of time. Make sure that my pen is on. So A is B, E, K, D, G, L, and I. And my set B is equal to F, I, J, and M. So I want to know, is B a subset of A? So I want to check to see if every element of B is also an element of A. F F is not. I is. J is not. M is not. So if I look at the difference of B and A, I still have something left over. I have F and J and M here. So when I draw a Venn diagram and I have A and B over here, we only have one element in the middle, and then I have F, J, and M over here, and then we have B, E, K, D, G, and L up over here. So we can see that B is not a subset of A, because not every element in B is also in A, and if we take the difference, we end up with something else. So I want to talk about proper subsets for a second. We don't use them very much, but it looks a little bit like less than. So, and it actually means kind of like that. And all the elements of A are also elements of B, which is the same as a subset, but B has more elements. So you can see on the left side here, here we have B has more elements than A, but on the right side, B does not have more elements than A. They have the same number of elements, and really they're equal. B and C are equal. So B and C, B is a subset, I'm sorry, C is a subset of B over here, and A is a subset of B over here, but A is a proper subset of B, but C is not a proper subset of B because there's not more elements. So I hope that was clear. We're going to do some practice on the board in a minute.